Hello everyone, welcome back to the channel. I'm your space weatherman Stefan Burns. We have had 3 X-class flares just in the past 48 hours, all from one sunspot group, AR 3947. We see that here with our 94 angstrom imagery, and this is for the past 2 days. So going back to the 3rd universal time all the way up to the present moment. And basically we see this thing going bonkers the whole time. Not just 3 X-class flares, a 1.2, then a 1.1, and now a 1.8. Also some M-class flares in between. Almost all the activity from AR 3947, though we see some other activity across the sun as well. Sunspots are over 200, so we are in a very active period right now with solar activity. At the very end of this clip, we do see this long kind of low magnitude solar flare coming off this part of the sun, the western limb rotating out, but it's AR 3947 that has everyone's attention because it's given us 3 X-class flares in just less than 48 hours. It's not even in the Earth direct bullseye zone. So it started to push out coronal mass ejections. We're seeing that in the coronagraph imagery. And if it continues to flare like this, then we are certainly going to have some significant solar storm impacts coming in, and the frequency and the strength of these solar flares would indicate that if that potential is to occur, they would pancake together and create a very significant solar storm impact combined, which could give us a very strong geomagnetic storm. And right now that's looking like the most likely probability. It's not the only probability, but as of right now, based on current activity, it's looking like the most likely probability. So we're going to do a very fast, complete space weather report, talk about some other factors that are in the background right now. We also have just these coronal holes here on the sun. They emit these high-speed streams. We're having that hit us right now. We'll look at the real-time solar wind. We also just had a flank impact from a coronal mass ejection that was launched right on New Year's Eve, basically as the clock struck midnight. That swept by, gave us a G1 storm. And so a lot to talk about in today's video, but let's zoom in on that 1.8 X-class flare that we just had, the most recent one, because that one is the strongest and the most recent. And this one pushed out a coronal mass ejection pretty clearly out into interplanetary space. Not Earth directed. It doesn't seem to be, but that is that 1.8 X-class flare. And so they've been ramping up. We had a 1.2, then a 1.1, but that 1.1 flare was actually a sequence. It was a C9.8 and then a M2.5, followed by that 1.1, and then an M1.9 and M5.9, and then a M1.5 again. So it had like this pyramid step to it. We'll see that with our X-ray flux in just a little bit. But that is that 1.8. You can see that again, we still have about probably 3 days, 4 days until it's here in that strike zone. So we're ramping up quickly and we're not even close to that Earth bullseye zone yet. So a lot of possibility and potential for this to evolve a lot more from how it's already behaving and acting, or it could peter out, expend its energy and rotate through Earth direct and center and go quiet, and we'll have that Earth-facing quiet phenomenon. That's very possible. We see that more often than you would think. We can also see here our coronal mass ejection that was pushed out from that flare very nicely with our 304 angstrom view. So we see the flare, and then we see that push of material from the corona outwards, and that has launched out into space. And look at the location here, close to the eastern limb. Right now, Earth, of course, is always going to be exactly center for these graphics. Well, Venus is off at that angle. So, in fact, Venus is going to be hit by all these different coronal mass ejections. It's been hit by the solar flares just like we have in terms of the light flux. Actual light photons, 8.3 minutes to reach Earth, a shorter time to reach Venus. But the coronal mass ejections are all launching towards Venus. So she's getting supercharged right now. Are we next in line? That is a big question. So let us go over to our real-time solar wind, because I want to show you this. This is the solar wind that we've just gotten out of, and we're actually kind of getting back into it right now. This is one day. So we had this coronal mass ejection impact there, just kind of a flank, but pretty significant. At the top, at the peak so far with this, we had an interplanetary magnetic field strength up to about 18. Right there, our top line, the black line is for the total magnetic field strength, denoted by BT, B standing for magnetic. And we saw that it just slowly climbed up, and then we had these southward components right there that all went sharply negative. That's the vertical component of the interplanetary magnetic field. A magnetic field, you can split it into a variety of different component directions. It's really a 3D infinite thing, but you can look at it X, Y, and Z if you want, or a 6-axis. There's different ways of doing it. They look at the vertical direction for the interplanetary magnetic field. Earth's magnetic field in general has a positive vertical direction. Whereas if this goes negative, now you have that strong connection, that injection of mass. And so this triggered a G1 storm, and it looks like we're just now kind of getting back into it. We see that going back down into this southward region, though the total field strength is going down. And we've had the solar wind velocity go up quite a bit. Here we see it ramping up. Then we get that coronal mass ejection impact. It stays elevated. And this is now that high speed stream, I'm pretty sure, because we're at values of about 540, high 500 kilometers per second. That could get enhanced slightly further by the high speed stream from those coronal holes on the sun, but we'll just have to wait and see. And we see the plasma density going down. That's usually kind of what you get with the high speed stream impact, because you get the faster velocity but lower density often. So that is what has happened with the real-time solar wind over the past day. And if we go to our HB30 and HB60 indices, we can see the type of geomagnetic volatility that we've had recently. And this puts things into perspective for sure. Here we have our HB60 index for the past 10 days. Here are the quiet conditions that we are in for a long time. Here we have that New Year's Eve geomagnetic storm, New Year's Day, went up to a G4 level on the KP index. It went up to 8 for 3 hours. On the HP60 index, it actually went to 9.33. So that's a G5 storm for 1 hour. That was pretty big. There's long-term energetic effects from that. I've covered that onto some of my recent videos. Then we see that we had this like substorm right there. And here's that flank impact and high-speed stream, bringing us back up to a G1 right there. And we see that if we go down to our KP index, we see our KP value of 5 right here, which is at G1. And then you have a G4, you have a value of like a G1 storm, but it's like a G1 minus, you could say, with a 4.67, then 4.33. So those are like unsettled but active conditions. And then we started to go back down. We'll see if that goes back up. It's unlikely, but again, if we start getting those X flares pushing in and those coronal mass ejections, which are possible, if that activity continues, then we could be looking at perhaps a repeat of this in about a week's time, or perhaps even stronger. We just don't know. But right now, the activity that we're seeing from 3947 has been bigger than the activity that gave us this right here. Let's look at our X-ray flux. And this is for the past 3 days. We see here how all of a sudden everything changed. And that's because 3947 rotated into view. So here's that first X-class flare. Here's that flare sequence that I mentioned, culminating with a 1.1 X-class flare. Here is this M7.6 flare right there. So pretty significant too. Independent, standing on its own. And here is this 1.8 X-class flare. And then we have this most recent high C-class flare right there. That's coming off of the western limb actually. But just very quickly, all of a sudden, solar activity jumped back up. If we go to our 7-day view, we can see that we didn't really get much of a break. We had a lot of solar activity here, and then we just briefly took a little dip down, not by much, and now we're ramping back up again. So that is the story as it relates to what we're seeing right now. We can look at our sunspots and how they've changed over time just recently. Here we have our gong imagery. And, you know, I wish we had the SDO imagery, but as far as I know, that's still offline at this moment in time. We see all the sunspots here, southern hemisphere. There's 3947. That's our big baddie. So we see it rotate in and we see it grow. So there's been actually some reduction of solar flux in some of these sunspots. For example, here that we have had a little bit of growth in some other areas, but 3947 just continues to grow and it's been the most active. So a lot of growth from that sunspot group, a lot of activity, and not that much from these guys. Some changes with them, but in general, on average, across the southern hemisphere, reductions in solar flux, increases in solar flux in the northern hemisphere. That is our most recent sunspot intensity grams from the Gong network. We also have our chronograph, and so we can see what's been happening from that 1.8 X-class flare. We can punch in on this right here for you guys and see what this looks like. We'll see at the very end the push coming off of this side right there. There it is. So it's just starting to launch out now. Some activity overall. There's another push, coronal mass ejection, all from 3947. And so if it continues to flare as it rotates into Earth direct zone, then these will start going from pushing off of towards the east and more towards us directly, kind of like this. So we'll just have to wait and see if we get that sort of activity, but it's very possible. Also interesting, there is like maybe these are stars. Yeah, it's the background stars. Okay, it's not some crazy UFO. But we also have our, what is this? We can see what's happening right now with our sun, just to give this a look really quickly. Then I have some other data I want to go through. So here's our most recent 3 hours of SUVI 131 imagery here. And we'll just position this. So we'll give this a watch. There's the tail end of that 1.8 X-class flare, and then we see this eruption coming off the western limb here. So now it's almost a sympathetic flare. We'll see if this sort of dynamic continues. But for the past 2 days, almost all the activity has been here, but now we're seeing a little bit of a sympathetic flare as a result of this sunspot group here waking up. So it'll be interesting to see if we have that dynamic come back, because we had a bunch of sympathetic flares at the end of December. Let us look at where that 1.8 X-class flare hit. Here's our DRAP model. I talked about this in depth, what we're actually looking at in yesterday's video. But we see that push of X-ray and extreme ultraviolet light right over the Atlantic Ocean. So almost the same location as the 1.1 X-class flare that we had. And that's basically like hitting not Easter Island, yeah. So it's hitting that Atlantic Ocean very nicely. We have a bunch of volcanic activity here in Ethiopia. That looks like an imminent volcanic eruption. I've covered that in yesterday's video. We just recently, past 24 hours, had a 5.8 magnitude earthquake from there. So interesting that we're getting all these solar flares kind of over Africa at this moment in time, when it looks like there's a very big rift eruption that's about to occur in Ethiopia along the Rift Valley. Not sure they're correlated, but they are correlated in time, which is interesting. So big push of light energy over this region. We'll see if we get more X-class flares over the next few hours and days, but I would not bet against it. Another thing too, we have our most recent space weather model from the UK Met Office here, and we see that flank impact right there sweep by. That's what we just had happen. We see a whole bunch of coronal mass ejections launched this way. Here are some of the coronal mass ejections that are being launched towards Venus, who's about here or so. So this does not show the most recent coronal mass ejection from that 1.8 X-class flare, but we can see this kind of wave of coronal mass ejections going this way. And if that continues, then they'll start to sweep more past the Earth, and we'll get that geomagnetic volatility as a result. So that's what the UK Met Office is showing. They were spot on with this coronal mass ejection flank impact. They had that for 3 a.m. Universal Time yesterday. In fact, that's exactly when that coronal mass ejection came in. That's why I like this space weather model. They are very accurate and they continuously update it like 2-3 times a day at a high quality. So this is a great model. They're pretty accurate, and we're seeing that all these coronal mass ejections sweep by Venus over the next few days, and maybe soon, if it continues, sweep by the Earth. Another thing that's also occurring, which is interesting, is that Earth is at perihelion today. And so this is the closest that the Earth is to the sun. There is variability within Earth's orbit. It's not a perfect circle. There is some change. There's a time when the Earth is a little bit closer to the sun and time it's a little bit further away. When Earth is at its furthest, that's aphelion, that would be about 1.01 astronomical units. But at perihelion, Earth is at 0.983 astronomical units, which is roughly about 147 million kilometers. And so we see the changes are in the size of the sun as viewed from Earth with this nice graphic here. So we see that when we're at perihelion, the sun appears slightly larger, and at aphelion, it's slightly smaller. Of course, the sun's not changing size, but because we're getting closer and further away from it, it is having this apparent change in size. And as you move closer to the sun, the amount of light radiation that you receive does increase. So for example, Mercury receives the most light radiation. It's like 9,000 watts per square meter, something like that. Venus is less, and at Earth it's at about 1,370 or so watts per square meter. Well, if you move slightly closer to the sun, that's going to increase because this light radiation decays via the inverse square law. So we are right now, because Earth is at perihelion, receiving slightly more total solar irradiance as a result of our orbit being, an ellipse and not a perfect circle. So that is in effect right now, and then we'll be at aphelion in about July. I think it's July, maybe end of June. It's about once we're on the other side of the orbit, so about 6 months later. Now there's some other data that we can look at, which is our recent, which is our recent sunspot, solar flux, and then also I want to talk about this Mars-Pluto opposition that we're having right now. So here we have sunspots going from December to January, and this is December right here. Here is January. We see this big ramp up in sunspots at the very end of December, over 250. And then we had that big solar storm sequence and that G4 storm. And that's what we've been seeing, is that when we get this big increase in sunspots, there's typically with that a big push of solar flux from the sun. And as a result, coronal mass ejection, solar storm impacts, and then we get a storm. This occurred in August, this occurred in October, now it's occurred in December. You notice the rhythm there, every other month. But what's been happening is that typically over the past few months, we've had this big spike and then we've gone down. It's been this regular rhythm, a big increase, and then those sunspots rotate out of view, and then sunspots on the Earth facing side go back down to like this region, like 100, 150. Well, this time, new sunspots have been rotating in, and I think they've actually been opening up really quickly on that Earth facing side, because we're not seeing them show up in the helioseismic data, which lets us get a rough view of what's happening on the far side. We haven't really been seeing them transit across on the helioseismic. All of a sudden, they've just been there. They've just been, hey, we're here. So now we've been seeing, with at least the end of December, beginning of January, sunspots staying elevated over 200. Here's our average for January thus far. We're only a few days in, but we are right at 200. And so if this continues, we could see a really high sunspot number for January. I think that's likely, but we'll just have to wait and see. Here is our solar flux, 2800 megahertz, from November 24th to January 3rd. This is November over here, and this is our recent data. So we see that we had this peak at the end of November, that rhythmic activity I've been talking about. I've shown this data before, but I want to give you the latest. Here we had this dip mid-December. This is actually when we had a whole bunch of earthquakes that occurred, high magnitude earthquakes. And then since then, those high magnitude earthquakes have dropped off as solar flux has gone back up. We saw that we were above 250 for a long time, and actually now solar flux is starting to go down even though sunspots have stayed elevated. So we are having more sunspots, or at least they're maintaining their overall numbers on the sun, but we have had this reduction in solar flux. But you see that here we are about 208 or so, and this is still pretty close to the high values that we had at the end of November. Definitely not as big of a drop like we did at the, going all the way down to this lull in mid-December. So we'll see if this charges back up again, stays relatively elevated over 200, or whether we drop under 200 soon. But when we're looking at the radio frequencies of the sun, honestly, it's a better measure of solar activity than sunspots, because it's an actual, an actual wavelength of light, whereas sunspots is just a feature on the sun. And they're useful and they help us track solar cycles, but they are not a prime indicator of the actual activity of the sun like solar flux is. And so we see that this has been a very broad peak of activity. We're coming down from it now, but like our X-ray flux is going up right now. Even though radio flux has gone down, now with all these X-class flares, X-ray flux has gone up. So there is some interesting stuff there. Now, here is a factor I want to talk about, because this takes us all the way out to April. We've had these Mars-Pluto oppositions. We've now had two. We're in the second one right now. The first one was on November 3rd. And then Mars, because of the location of Mars, Pluto, and Earth in their orbits, Mars is apparently moving retrograde through the sky. But what this means is that we effectively are creating this like gravitational vector between Mars and Pluto because of our orbit and their movement through their orbits for about 5 months or so. About 5-6 months. And so it hasn't been 100% exact during that entire time, but very close to exact for like 5 months. And so we had the first one November 3rd, and this is when Mars is moving forward from our perspective, but this one from January 3rd is a retrograde opposition where Mars is apparently in our night sky moving backwards. And then on April 26th, Mars will be in a forward movement again along with Pluto, and it'll be another opposition. Now, the reason I'm bringing this up is because we see rhythmic activity, reflected across the universe. That's just a natural manifestation of our reality, is that we have these rhythms, these cycles, right? Actual waves, sine waves, things of this nature. So here we have a really nice wave. We have the first wave here, and then we go down like this, and then we go up like that, or it could be down, up, down. But we see this really nice rhythm here where Mars is moving forward and then backwards and then forward again. And so I wanted to mention this because if there were any things that you were thinking about, or anything that was occurring both for the Earth or for yourself or different, let's say, communities or groups or technologies, whatever, right? You could look at what was occurring on the 3rd of November, what's occurring right now, and then also what may happen on the 26th based on this rhythmic activity as it relates to Mars and Pluto. Here we have Solar System Scope, which is just a model of the solar system, allows us to view planetary geometries really nicely. And we can see that Mars-Pluto opposition that is exact right now. Here we have Mars, there's Pluto, and here is the Earth. Also allows us to see the fact that Venus is getting hit with all those coronal mass ejections over the next few days, because that sunspot group is basically right in this zone right now. So definitely the coronal mass ejection from that 1.8 X-class flare will sweep by Venus, and then we may be up next. But we are right now in this opposition between Pluto and Mars, and we've been in that effectively now for already about 2 months. And this is that retrograde one. And then if I click the Earth forward here, we see that Mars is moving right with the Earth. And we see the next Mars-Pluto opposition occur. Let's get our time up. I think I turned the time away. Yeah, so we get this going. We have to go all the way to April. But before we do that, let me actually show you this planetary geometry that we have right here: Earth, Venus, Mercury, the Sun. I'm not expecting, but I would definitely be. I'm watching this closely because we could get some significant solar flares or earthquakes at this moment in time because of this planetary geometry in late March. It's possible with Neptune and Saturn off over there, fairly close along that alignment on the other side of the Sun. It's possible. But if we go forward to April, we see now that opposition starts to click back in again as Earth starts to move along its orbit. I move over here for you all. And I think it's actually right around April 26th that we get that opposition again. So we are in this opposition right now. I go all the way back to today, the 4th of January. And you can see that opposition again right here. And then we move forward all the way through April. You wonder how it's going to happen because the Earth is ahead, but all of a sudden, because we are along our curve in our orbit, we see that this opposition clicks back in right there. So this is a dynamic that's going to take us all the way into April. And we've been seeing this strong solar activity since these oppositions first kind of clicked in. And I think there's going to be a wave function to it. I think this retrograde one is moving backwards. I think this will be kind of an inverse characteristic as to what occurred November 3rd or so, and then also what may happen in April. So just wanted to bring that to your attention. And that is the space weather update for today. Thank you all so much for watching. I'm wishing you all well. I'll keep you up to date as to what is happening with the sun, with the solar system, with our Earth geophysically, because there's a lot that's been happening. Big energetic amplifications occurring on our planet. And we could have a really big volcanic explosion soon in Ethiopia. Not sure this is going to manifest as like a rift eruption or like whether Dauphin volcano or Fontal volcano will actually explode. They are stratovolcanoes, so they could have just an actual explosion. We just don't know, but we've seen extreme earthquake activity out of Ethiopia, a concerning amount. And now the people in Addis Ababa are feeling these earthquakes very strongly. So that is something I'm watching very closely. I think we're going to have big volcanic activity there occurring very soon. I'll keep you up to date every step of the way. I also post interim updates on my Twitter X account at Stefan Burns Geo. So you can go check that out if you want to stay up to date in between. And yeah, again, wishing you all well. Thank you all for joining the live stream. And I'll see you all in a future video.